In this video, we will discuss the concept of modified duration. Let's consider a bond with face value of $1,000. The current price of this bond is $964.54. The bond matures in 2 years' time. Coupons on this bond are paid semi-annually at an annual coupon rate of 8%. And the yield on this bond is 10% per annum with semi-annual compounding. And finally, Macaulay duration of this bond is 1.88 years. Bond traders often use Macaulay duration as a measure of bonds' price sensitivity to changes in interest rates. But we know that Macaulay duration is better used to estimate weighted average term to maturity of a bond's cash flows. However, modified duration, denoted by D with a subscript MOD, is a better measure of approximate sensitivity of bond price to interest rate changes and is calculated as follows. Bond price if yield declines minus the price of the bond if yield increases divided by 2 times the initial price of the bond times change in yield, denoted by delta Y. So in case of our bond, if yields were to increase from 10% to 11%, the new price of the bond equals $947.42. We assume in this video that viewers are comfortable with pricing a bond, which is covered in the video on bond pricing. On the other hand, if yield declines from 10% to 9%, the new price of the bond will equal $982.06. So we know what new bond prices would be if yield were to go up or down by 1%. So in this example, modified duration equals the price of the bond if yield were to go down by 1% minus the price of the bond if yield were to go up by 1% divided by 2 times the initial price of $964.54 times the change in yield of 1%. Note that we got these new prices after changing yield by 1% in each direction. So in this example, modified duration equals 1.8. This means that if yield goes up by 1%, bond price will come down by 1.8%. And if yield goes down by 1%, bond price will go up by 1.8%. Another quick way to calculate modified duration is by taking the Macaulay duration and dividing it by 1 plus the yield to maturity divided by M, where M is the number of times yield is compounded in a year. And in our example, this equals Macaulay duration of 1.88 years divided by 1 plus the yield of 10% divided by 2, since it's semi-annually compounded. And this equals 1.8, which matches the modified duration we got earlier. Since modified duration is a measure of bonds' price sensitivity to changes in interest rates, the change in bond price can be estimated using modified duration as follows. Negative of modified duration times the initial price of the bond times change in yield. So when yield goes up from 10% to 11%, the change in bond price as estimated by modified duration equals negative of modified duration, which is 1.8, times the initial price of the bond, which is $964.54, times the change in yield of 1%. And this equals negative $17.32. So the new price of the bond equals original price of $964.54 minus $17.32, which equals $947.22. This new price, estimated using modified duration, is slightly less than the actual new price when yield is 11%. But as we can see, modified duration does a fairly good job at approximating the price change. Similarly, when yield decreases from 10% to 9%, the change in price equals negative modified duration of 1.8 times the initial price of 964.54 times the change in yield of minus 1%, since yield declined from 10% to 9%, and this equals $17.32. So the new price equals the original price of $964.54 plus $17.32, and this equals $981.86. Again, we can see that duration has done a fairly good job in estimating the price change, but this $981.86 estimated using modified duration is again less than the actual new price of $982.06 when yield declines from 10% to 9%. So in both cases, we can see that modified duration is a good proxy to approximate changes in bond price due to interest rate changes. However, in both cases, modified duration has also underestimated the price of the bond. We can explain the reason for this graphically. Note that this yellow curved line shows the inverse relationship between the price of a bond and its yield. When we calculate duration, we are essentially estimating the gradient of a line tangent to this price-yield curve at a given yield, which in our case is 10%. So any change in price resulting from change in yield would be approximated by this tangent line. So when yield decreased from 10% to 9%, the resulting new price was estimated by the straight tangent line, which gave us the price of $981.86. But that lies below the price yield curve, which at yield of 9% would have given us the price of $982.06. This difference in two prices is called the measurement error. Since this tangent line always lies below the price yield curve, it will always underestimate the bond price due to change in interest rates. Finally, let's look at how duration performs when yield changes by a large magnitude. Suppose that yield changes by 300 basis points, so that yield increases from 10% to 13%. In that case, the bond price will go down to $914.36. However, new price approximated using modified duration equals the original price of $964.54 minus modified duration of 1.8 times the initial price of $964.54 times the change in yield of 3%, which equals $912.59. On the other hand, when yield decreases from 10% to 7%, the price of the bond at this new yield of 7% equals $1018.37, whereas the new price approximated using modified duration equals the original price of $964.54 minus modified duration of 1.8 times the original price of 964.54 times the change in yield of minus 3%. Since the yield declined in this case from 10% to 7%, the change in yield is negative 3%. And this new price equals $1016.49. There are two things worth noticing here. In both cases, whether the yields went up or down, the new price estimated using modified duration has been below the actual price at that new yield. And secondly, the measurement error, calculated by subtracting the duration-adjusted new price from the actual new price at the new yield, in both cases is greater than when it was when yields only changed by 1%. So we can see that measurement error gets larger with magnitude of change in yield. So it can be concluded that modified duration is a reasonable proxy to estimate changes in bond price due to small changes in interest rates, but it does not do an equally good job as the magnitude of rate changes gets larger. If there are any questions or comments, please feel free to post.